Hi, this is Dr. Kraus. I want to record a quick video on how to use the updated serial utils module that is installed on your Raspberry Pis. I've got a slightly older version of VNC, so it might not look exactly like yours, but just to review the steps. Whoops, I changed my password. So launch VNC, knowing the static IP address of your Raspberry Pi, log in, and then launch the Jupyter Notebook. And JU up arrow should be all it takes because all of your Raspberry Pis should have the Jupyter Notebook command in their history. If you're prompted for a password, you should know what the Jupyter Notebook password is. It was on a piece of paper given to you with your Raspberry Pi. So I guess I should back up here. Motivation-wise, big ideas. The way that we've been using serial utils in lab is pretty good, but I think has at least one kind of annoying thing, is that we were redefining the helper functions read all, print all, and get data. Some of you, every time you ran a notebook, you just kind of just re-execute everything, and so it just takes a few seconds. It just takes up a little bit of space. It's maybe not a huge deal, but it's kind of annoying. And that's going to get worse on the Raspberry Pis because you're going to have a slightly smaller display most likely, and there'll be a little bit of network lag, and your scrolling may or may not be less smooth than you're used to. Certainly it is for me. I don't have a scroll wheel per se. So doing a two-finger scroll is a little bit clunky over VNC. So I just didn't want to have to do that, and was also kind of borrowing a suggestion from one of the students that it'd be cleaner if all of those things were somehow wrapped into serial utils. So what I did was create a new version that is object-oriented, that has read all, print all, get data, write int, write byte, write char, write float, all folded into this that I'll show you. The code is already on your Raspberry Pis. If you want to get the most recent version of this on your laptop, then go to here. And that link is also on Blackboard. And then just save over wherever you had serial utils previously installed. And if you're not sure where that was, I also put on Blackboard a little demo file to use the import module to see where did I put that? So lectures, this is lecture 19, and updated serial utils. So it's on Blackboard, import lib demo. What this does is by using the import lib and specifically reloading the serial utils, the output of that should be the full path of where you currently have serial utils installed. So go to the new link that's on Blackboard from my GitHub and save the new serial utils over top of wherever you had the old serial utils, and then you should have the new code on your laptop as well as on the Raspberry Pi. Okay, and the big idea then is when I want to create a serial connection, I'm going to use serialutils.serial_test and the port name, and the example Jupyter notebook that's on your Raspberry Pis has a fancy way to get port name, and so that should all work. And so this now gets you the object-oriented serial test that has the helper functions built in. So every time I connected, and I could demo this, but I would do a .open, .print all, and then .flush. If you flush before print all, then you're going to miss any welcome messages that you have connected to yours. So I'm over here on my Raspberry Pi over VNC, and in the helper notebook that's on your Raspberry Pis that's in the SBR Git repository, it also does a reload and checks where serial utils is coming from. If it's not coming from the /home/pi/sbr git folder, then I let you down and screwed up your Python path on your Raspberry Pi, and we need to fix that. I'll double check them all, but let me know if you see that. And then it figures out your operating system based on the platform module, and then it knows that it's in Linux. And then if it's in Linux, it calls serialutils.find port name, because that thing can potentially increment, and then it does the connection. So like I said, I would do these three commands. So first I create the instance using serialtils.serialtest parentheses port name, and then I'm going to open it. I'm going to print all. If that's blank, I would recommend going back. If you know there's a welcome message, go back and print all again. Then I'm going to flush. And now my Arduino's in its menu. And so, for example, I have a calibrate function, and I don't have my USB camera hooked up, but I promise you that my robot is now calibrating its sensor. Oh, it's going to fall off the table. Okay, and then when that's done, I'm going to print my calibration results, and that's pretty typical for me. Like I said, my IR line follower sensor is a little bit high, and my white is not super glossy, and so it takes a couple hundred microseconds before it, oh boy, that's not good though. Okay, whatever. This is about the serial utils, not about my robot specifically. So there, Sir has a write char method. If I wanted to test it out with autocomplete, I could type WR and hit tab. There's a write byte, write char, write float, write int, write string. So all of those are available to you to send those different data types as ASCII strings over serial. So it converts the float to a string and sends it, and then you would read it on the Arduino side with a parse int, parse float, and so on. Okay, so those are the four data types that you can send. Technically, I wouldn't use write byte by itself because that's expecting an integer out of the ASCII table. And so write char takes one character, looks it up in the ASCII table, and sends that to write byte. So write byte is kind of like a helper function for the rest of these. And so write char becomes a helper function for each of the other three. So write string would actually just call write char for each character. And then write int converts that to a string and then calls write string, which calls write char, which calls write byte. Similarly, write float converts that to a string, passes it to write string, which passes it to write char in a loop, which calls write byte each time. Woohoo! And then you have the .readAll or .printAll functions built in. And when I say object-oriented, what I mean is that there's this Sir is an instance of a class, and then it has all these functions available if you do Sir dot and then other things. And then you've got Sir.getData, which we would use in exactly the same way we have been using the getData function. It's just now rolled up underneath the serial test class. And then if for some reason you were having troubles programming your Arduino with Python open, you could use Sir.close to close the connection. So pretty straightforward. I think this will help you. I think it will mostly, like I said, if you look at my notebook, I don't have nearly as many cells of things that I'm just kind of randomly defining. Now I added a couple of new ones to try to find the port name. You could hard code the port name if you wanted to, although under Linux I would use this function instead. And I did that so that you could unplug your Arduino from the Raspberry Pi and use the long USB cable, and you could have your own port names specified for Windows or Mac if you wanted to do that. And so that's what these two cells together do. And I did not roll data to float array inside the class because I wanted you to be able to tweak this if there were things that you were looking for the start of your data or the end of your data, or however you wanted to filter it as needed. So I left that one. Okay, let me know if there are any questions. Thanks.